Hi guys, and welcome to the next video. Today we're going to talk about payload because we've done the mastering, we've done the frames, we know how to jog the robot, and that will be kind of a next topic that we need in order to get our stuff ready, because to create your first program it's nice to know your tools, your frames and your payload, as well as check the mastering. Alright, so like always guys, I hope that you've seen on the previous videos I started adding like on the timeline, on the time bar, actually sections, so it's easier for you to find the information that you need faster. I think it's cool. So you will have the intro stuff, then today it's going to be payload, armload, and the end of the video. Okay, so let's get started. Okay guys, so the payload, what is it? Why do you need it? So the payload is going to tell your robot how much weight he's carrying on his arm tooling. So the tool that you mounted, you need to tell him, hey, it weighs this and this much. Why do you do it? There are a few options. First, so the robot is more accurate. Second, so the collision detection works better. Third, that the soft float function works better, and it should help you with the cycle time. Why? And what did I observe myself during the programming? So without the correct payload, the robot doesn't know how much weight he's carrying, and by default he thinks that right at the flange he's having like the payload defined by the robot type, so let's say 165 kilograms. And you gotta tell him, oh wait, that's not this much, it's this much or that much. Why? So I will make a short demonstration. So look at my hand right now, and you can make the movements like this pretty fast, right? Because you know when you're going to stop and how much time does it take and how long you need to brake in order to stop at the point. Now let's add payloads. I'm going to use a bottle of water. So now I have bottle of water, right? Now when I make the movements, they are not so accurate because I got the account for the bottle, right? So when I move, I want to know how fast I need to accelerate, how fast I need to brake, and how the movement should look like. And that's why we're using the payload, to help the robot to be more accurate. Also for the collision detection, right? When you hit your hands together, it's pretty soft, but when you take the bottle of bottle of the water and you hit it, well, you've seen my hand, right? If I knew that I'm carrying that bottle, I would stop earlier because I know I have that weight and I gotta compensate for it. So that's why you're using the payload, and that's what the payload is for. So what you're going to define on the payload? Well, the first thing is the weight. So you gotta either know the weight, or you can identify the weight with the payload function. That I do not recommend. It's really better, guys, that you weigh your tools or get the data from the engineers and so on, because the FANUC like payload detection, the weight detection is not too accurate. So I highly recommend to get that data from somewhere. Okay, that's the first thing. So you will get your weight. The second thing, you need your center of the mass. So you gotta know where the center of the mass is, because like that water bottle, right? Probably the center of the mass is going to be, I don't know, somewhere around here. Because not you, but the robot needs that for the calculations. And the third thing is the moments of inertia that you need to have. So while the robot is moving, he needs to know like what's going to happen with the tool. And you can get all of those data. There are two methods how you can enter the payload data. One is the manual entry. So that's what I'm saying. You get the data from the engineers or from the CAD or from the simulation, and you'll just manually type it into the robot. That's the first one. The second one is that you actually mount the tool on the robot, and with the payload ident options, you're going to define your payload. So the robot is going to do a movement like this with rotating axis 6, and he's going to determine his moment of inertia and the center of the mass. And we're going to do that on the exercises. The other thing that has to be defined is the arm load. And the arm load is you need to tell the robot how much weight he has on axis 3 and on axis 1. So imagine like having a backpack and you walk with the backpack. You want to know how much weight you have in that backpack. The same for the robot. Why? Because when you place something on it, the harder you will push or the more weight you will have has to compensate for that. And that's why you need the arm load. Okay guys, let's get to the exercises. Okay, hi guys and welcome to the exercises. Okay, so we're going to talk about payload today. As you can see, I've added another tool to our robots. That's the tool we want to set the payload on. So what we gotta do? First of all, we go back to menu, we go to next, system and motion. So number 7. And in here, if you don't know the robot payload, normally the robot payload is going to be written somewhere in here on the robot arm on axis 3. And if it's not written and you go to the payload menu, the default value in here that is shown is going to be the default payload for the robot. So for our small guy, that's 7 kilograms. And you have 10 payload schedules. You can extend it to 32 payloads if you need, but that's what we have for the payloads. Okay, so you can select the payload by doing the I'm sorry, wrong button, by jogging with the arrows, and then create the payload for this payload schedule. So let's pick number 3. And what you want to do first is go to detail to make sure that nothing is inside. As you can see in the payload, like I've said, we have the weight of our tool, then we have the center of the mass, and then we have the inertias, moment of inertias here. So like with the TCP and user frame, you need to make a name, guys. It's always a good name to create a name. So let's do it. Let's hit enter. And let's put a name for it, because it's a glue gun or sealer gun. I'm going to use the name glue gun. Okay, now that's a manual entry. I'm going to show you first. So if you have a drawing from the simulation or the CAD, or you have values of your payload from the simulation, you can go ahead and put them in. So if we know that our tool has 6 kilograms because the documentation says so, you're going to input number 6 in here, and it says path and cycle time will change. Do you want to set it? Yes. You want to do the payload center. Probably that one is going to be, I don't know, let's use any values, guys, in here. Doesn't really matter right now, it's just for the test. I just want to show you how it looks. And there you go. That's why the payload is important. So as you can see, I'm telling the robot that it has a 6 kilograms on it. And now I'm telling that 6 kilograms, the center of the mass is moved 15 centimeters out of the faceplate. And right now I'm getting a warning that load is close to capacity. I want to accept. Let's click yes. Now, see what happens if I say that it's only 3 centimeters. It says path and cycle time will change. Do you want to set it? Yes. Why? Because the robot knows, guys. If I put 15 centimeters, that's already too much for him, or it's very close to what he can handle. That's why the payload is so important, because if the weight will be too high for him, you will get the disturbance excess errors, which are the errors that the motors are at maximum, or you're going to get just collision errors because the weight is too much for the robot to handle, or you're going to have inaccurate robot, or your collision will not work, collision detect, and so on and so on. That's why it's so important to do the payload right. Okay, let's say the payload center is 1 centimeter in Z. Yes. I'm sorry, in Y. I don't know, 5 centimeters in Z. Yes. and you gotta come up with the payload inertia. I'll just put the random numbers like I said. So like I'm saying, you will do it according to the documentation that you will get from the engineers, and there you go. You can again guys, I put too much. There you go, and we're good to go. Our payload is set according to the values specified by the engineers or simulation. So that was the manual entry for the payload. We can go back, and as you can see, right now everything is here. The payload is set to 6 kilograms. We have our command for the glue gun, and that was the manual entry. Now let's do the payload using the payload ident function, which is going to automatically calculate all of the values. So let's select payload number 4 right now. Go inside. Oops, sorry, detail. Again, let's make a name for it. There you go. Now in here, guys, you don't do anything. We need to go back. And now in here, we gotta go to the next. And we're going to do idents, which is payload identification. And in here, what you can do. First is you gotta say if the mass is known. And you always want to know the mass of your tool. You can say no, and FANUC will try to determine how big the tool is. However, it's inaccurate, and I do not recommend. It's like a last resort. So you want to say yes, and you want to put your weight of the tool. Let's say it's 5.5 kilogram in our case. Now, the calibration mode, you want to have it off. That we can cover in a different topic. That's used for something else. It's set for like when the robot comes out of the factory and you do like a base calibration of it. Don't use it now, just keep it off. All right. Now when we have this, we have our mass set to known and everything looks fine. We want to go to the next and we want to go to detail. And in here you have two positions. You have position 1, and when you click that button, you're going to move to position 2. So those are the two positions that FANUC will use for the payload determination. And you gotta define them. The position that I'm in right now is the perfect position for the payload. So that's where axis 2 and axis 3 are at 90-degree angle. We're starting with 90-degree angle on axis number 5. And then axis number 6 doesn't matter. So what the payload will do, I will move just axis 5 and 6 up and back down, and that's our payload determination. We'll move at a very slow speed first, so that's the first speed that we move. So we're going to move at 1%, then we're going to move at 100. You can change those values, however, for both speed and acceleration. However, it's not recommended. It's always best to do it with those settings. Definitely do not change the acceleration. If you will get to a trouble with setting up the payload, you can change those values, because sometimes the tool will be very close to robot capacity and he won't be able to do the payload. I recommend then to go down with the acceleration a little bit, and then you should be able to do it. Okay. So, how do we define the positions for the position 1 and 2? Two ways, guys. One, you can put in the values in here. So I can put minus 80 and let's say minus 60 as my first position. So if you want to check where that position is, you're going to hold Shift, hit Move to, and the robot will move to that position. The second way is you can just jog the robot by hand. Let me just slow it down a little bit. So you can jog it to any position that feels comfortable, or any position that you know the robot is able to do the payload. You can hold shift again and hit the record. And as you can see, the values will change automatically. So we have our first position saved. Now we want to save our position 2. So we're going to click position 2. As you can see, it's changed. There you go, you have the values. And you can just hold shift, do move to, and the robot is going to move to that position. Again, you can change those values by hand. You can record that point, and you're going to have the position 2 saved. Now, guys, very important. Or you can just, if you don't like it, you want to go back to whatever it was, you can hit the default button, and it will change back to the default values. Now, guys, what's very important, always when you leave that menu, make sure that you are in position 1. Because whenever you will start your payload estimate, the robot will always by default move with the full speed to the first position. So don't be surprised if your robot starts moving. That's because it was not in the position 1 when you started executing your payload. Alright, let's go back to previous. So guys, we have our positions specified, right? We have the mass known, we're ready to do the payload. As you've seen, maybe I will show it again, the robot will move from position 1 to position 2. So we are in position 1, when we move to, he will move to position 2 like this. It will not do any other movement, and then it will go back. So that's your movement, that's how you test your payload, and you know that the path is collision free. So don't worry, there won't be any other movements, that's all. Okay, let's go back. And what we gotta do is we need to execute it. So you wanna hit shift and exec, but you gotta do it in the auto mode. So you gotta turn your teach pendant off, because otherwise cannot execute in T1, T2. So we gotta go back to auto, and right now we gotta execute it. And it says robot will move from the estimation at the low speed, and then it will change automatically to the high speed. And remember, the robot will always start at position 1, and by default, when I will hit yes right now, the speed will change to 100%. So if your robot was not at the first position, it will move to it automatically. Well, actually, let me show you. So let's move axis 5 a little bit. Okay, let's try to execute. We hit yes. Look what's going to happen to the robot. See, it moved automatically to the first position, and that's our payload starting right now and running. So as you can see, the robot is moving from position 1 to position 2 at the low speed that we defined, which was 1% with the low acceleration, which is by default 100, and we leave it like this. Now it's going to go back to the first position at the low speed. And after that, after like a second of the delay, he's going to make that movement at the full speed. So he's going back to position 1, he'll change to full speed automatically, and he's going to move at the full speed. There you go. Boom. And as you can see, we've got some values here, guys. So we did our payloads, okay? Let's turn the pendant back on. The next thing you want to do is you want to apply your parameters. So when you hit apply, it will ask you, path and cycle time will change. Do you want to set it? Yes. And right now your payload is defined. So when we go back right now and we go to detail, we've got some values in here. Now guys, the value that I got doesn't make any sense because it's a simulation, so that's not a real value, but you always gotta check if those values make sense to you. So the Z minus would mean that the center of the mass is actually moved back by 8 centimeters, which is not true, because as you can see, it's probably somewhere around here. So just so you know, when you take a look at the robot when it's at the 0 position, your Z plus is that direction, so whatever value we'll get in here, it has to be like a positive value, and that means that your center of mass is moving towards here, so out of the robot flange. Then when you are at the 0, the x plus is pointing up, so this way. So in our case probably it's going to be in here, and then your y, according to the right hand rule, is going to point to here. So it's good to know where those values are, because you need to check if the numbers make sense. For me it doesn't make sense. Again, it's just a simulation, guys, so it's not a real robot. All right, there are a few more buttons in here. Probably you want to know what those are. So let's go back to an empty one. So the group is to change the group number if you have other robots or some other tools that you need to define the payload for. But it's only one robot, so there is only one group. That's why we're not able. Then we have a number, and that's because we can change the payload number. We don't need to go back. We can select number 4, the one that we defined, and it changed the schedule number to number 5. I'm sorry, let's go to number 3. And default is going to do default values for the robot. I've never used the default ones. I don't know, guys. To be honest, I don't know where does it take from, so I've never used it, just so you know. Then on the one that we've defined, we can use actually the one that is not okay right now. Set is doing the same thing, so we're just setting the active payload with it. So what's the difference between the number? That is changing our schedule that we're going to change, and this one, the set ID, that one, it's going to activate your payload. So because we defined payload number 4, you want to do number 4 and set enter, and it says active payload number 4. That means right now, whenever you're moving the robot, you are moving with that payload activated, but that we're going to cover on the program creation. Okay, and when you go to the ident, the same thing. The group, we don't have any other group. The number, the same thing. We can change the schedule number to a different value and edit it from here. Yep, and that's all. The other one we've checked. So that's all from the payload, and the last thing left is the Armload. So you gotta hit the Armload button in here and simply just put in the values for whatever you have on axis 1, let's say 2 kilograms, and whatever you have on your axis 3, let's say 3 kilograms. And it says do not forget to power on off after you add those values. And guys, that's all from the payload. So you've learned how to do the payload identification, the automatic one. You know how to add the Armload to the robot, and you know how to add the payload manually. That's all. So right now we have the frames, we have the mastering, so you know how to check the mastering, and we have the payload, and those were the 3 things that you needed before creating a program, because we're going to use our payload, our frames, and we need to check our mastering before we create a program to start. Okie dokie, guys, that's all from the exercises. Thank you. Alright, guys, and that's all for today. I hope you enjoyed the video. Don't forget to like, subscribe, and comment. Of course, comment, guys. Let me know what you want to know, and see you in the next video. Bye bye.